For this next video, we're going to be looking at finding the arc length of a circle. And so first, an arc length is a portion of the circumference of a circle. And you can use the measure of the arc to find its length. So for instance, the arc length, we may be trying to find the arc length of AB. So AB is just a portion of the circle. Now I want to find the length of that arc. And so in a circle, the ratio of the length of a given arc to the circumference is equal to the ratio of the measure of the arc to 360 degrees. And so we really get two different equations that we have there. And so I have that the arc length of AB, so what's in red here, over 2 pi r, which remember that's just your circumference, is equal to the measure of arc AB, which we have learned how to find in earlier lessons, over 360. And then another way that you can write that is you have the same thing, but I just multiply that 2 pi r to the other side. So again, this 2 pi r is the same thing as c. I could also write this as pi times the diameter. So you could replace that with any of those three. So let's go ahead and get some practice with actually finding arc length and using these formulas. So for this, I want to find each indicated measure, and I'm going to round to the nearest hundredth. So first I want to find the arc length of AB. And so I know from my theorem here that the arc length of AB is the measure of AB over 360 times the circumference, or 2 pi r. So I know that this is equal to the measure of AB over 360 times 2 pi r. Well, I see that for the measure of AB, remember that the measure of that arc is just equal to its central angle. And so I see its central angle is 60. So that means I have 60 over 360 times 2 pi, and then my radius I see here is 8. And I'm going to go ahead and multiply everything on top. And so I have 60 times 2, and I get 120. And then 120 times 8, I get 960 pi divided by 360. And then I'm going to go ahead and head over to Desmos and type that in. So I have 960 pi divided by 360, and rounding to the nearest hundredth, I see I get 8.38 centimeters. So the arc length of AB is 8.38 centimeters. Okay, now this next one's asking me to find the circumference. And so looking at this picture, I see that I have the central angle is 40 degrees, so I know that the measure of arc XY is 40. I know the length of XY is 4.19, but I want to know what the entire circumference is. And so to do this, I'm going to be using this top formula, but instead of writing 2 pi r at the bottom, I'm just going to be writing c, because I'm wanting to find what the circumference is for this problem. So I'm going to have that the length of arc XY over C is equal to the measure of XY over 360. Looking at my diagram, I know the length of arc XY is 4.19, so I have 4.19 over the circumference is equal to the measure of XY, which I see is 40, over 360. And then now from here, I'm going to go ahead and cross multiply. So I have C times 40, and I get 40C is equal to 360 times 4.19, and I get 1508.4, and then I need to divide both sides by 40. And I get that C is equal to 37.71 inches. So my circumference is 37.71 inches. Okay, let's try one last problem. Here I'm actually wanting to find the measure of arc RS. So I want to know what its measure is, that degree. And so I'm going to be using this same setup. So I have that the length of arc RS over, this time I'm going to use my 2 pi r, because I see in this diagram I am given my radius. So I just want to use 2 pi r here. It's equal to the measure of arc RS over 360. Now I'm going to go ahead and plug in what I know. I know that the length of RS I see here is 44 meters, so I have 44 over 2 times pi times r, which is 15.28. It's equal to the measure of arc RS, I don't know that, that's what I'm trying to find, over 360. And then from here I'm going to cross multiply. So I have this, so I'm going to go ahead and multiply 15.28 times 2, and I get 30.56 pi times the measure of arc RS. It's equal to 44 times 360, which is equal to 15,840. And then I'll divide both sides by 30.56 pi. So I'm going to go 15,840 divided by 30.56 pi. And I get, rounding to the nearest hundredth, 164.99 degrees.